In this video, I'm going to introduce redox reactions. The essential question that we're going to answer is, how do oxidation numbers help us understand and predict redox reactions? All right, so what's a redox reaction? Well, it's a chemical reaction involving the transfer of electrons between substances. And there's two processes that occur in a redox reaction. You have oxidation, which is a loss of electrons, and then you have reduction, which is a gain of electrons. And in a redox reaction, one substance will always be oxidized and another is being reduced. Now, you do need to know the difference between oxidation and reduction, but don't worry, I have a really easy way to help you remember. So, Leo the lion says grr. Leo the lion says grr. So, that means a loss of electrons is oxidation. A gain of electrons is reduction. Okay, so again, Leo the lion says grr. Loss of electrons is oxidation. Gain of electrons is reduction. So that's how you can remember the difference between the two. Okay, now before we can dive much further into redox reactions, we have to look at oxidation numbers. Okay, so oxidation number has to do with the number of electrons gained, lost, or shared when bonding. Okay, now this is an important thing that you need to understand. Oxidation number is not equal to charge. They are not the same thing. There are some cases where the charge will be equal to the oxidation number. However, do not associate charge and oxidation number as being the same thing, because that's not what they are. So we're going to go through some rules for assigning oxidation numbers. The first rule, when you have elements in their elemental form, such as oxygen, nitrogen, or hydrogen, their oxidation number is 0. That's it. Monatomic ions, such as sodium, which of course has a +1 charge, and chlorine, which has a -1 charge, the oxidation number is going to be equal to the charge of the ion. So again, oxidation number is not the same thing as charge. However, in this case, it is. They are the same thing. So that is only for monatomic ions. Okay, hydrogen has either a +1 or a -1 oxidation number. So if it's bonded to a nonmetal, so chlorine in this case is -1. So hydrogen would be +1. In this second case, sodium is +1. So that means that hydrogen would have to be -1. So you kind of have to look at what it's attached to determine its oxidation number. So again, hydrogen, we usually assume it has a charge of +1. It's not the same when it comes to oxidation numbers. Okay, oxygen in most compounds will be -2. It's pretty safe to assume that oxygen is going to be -2. Peroxide, which is H2O2, in this case, oxygen will be -1. So let me just explain how this happens. So hydrogen is +1. I know hydrogen is +1 because oxygen in this case is a nonmetal. The sum of our oxidation numbers in this case is going to be 0. So in order for this to work, oxygen has to be -1. Okay, but that's only going to happen when you have a peroxide. Okay, the rule for oxygen in most cases is going to be that will be -2. All right, group 1, 2, and 7 will follow the same rule as charges. So group 1 on the periodic table is always +1. So its oxidation number will be +1. So sodium is in group 1. It will be +1. It will have an oxidation number of +1. Group 2 is always +2. So again, magnesium in this case will be +2. And then group 7, it says it's -1. That's pretty much the rule that you're going to have, except when bonded to oxygen or other halogens with higher electronegativity. So oxygen is usually going to be -2, but in some cases it may be -1. It really depends on the situation. Okay, so pretty safe to assume that group 7 is going to be -1 in most cases. All right, we have a couple more. So neutral compounds, so that would be a compound without a charge. So like sodium chloride, no charge. Its sum of oxidation numbers is going to be 0. But in the case of sulfate, which is SO4 with a -2 charge, the sum of our oxidation numbers is going to be equal to the charge of the ion. So let me just go through the math here. So we know that oxygen is -2. There's 4 oxygens. So -2, -2, -2, -2. And then I have sulfur. We don't really have a rule for sulfur because sulfur is in group 6. And I know that this has to be equal to -2. So if I add up all of the negatives, that gives me -8. So in order for sulfur to make this statement true, it would have to be +6. So if you don't have a rule like we did in the case of sulfur here, or we didn't have a rule in the case of sulfur here, I look at the rules I do have, and you should be able to figure it out based on what information you are given or what rules you have. So let's look at this example. We have KMnO4, and it says assign an oxidation number to manganese in this example right here. Well, we don't have a rule for manganese, but we do have rules for potassium and oxygen. And if you notice, there is no charge. So it is going to add up to 0. So potassium is going to be +1. And the reason it's +1, it's in group 1. Okay. Oxygen we have a rule for. Oxygen, this is not a peroxide, so it is going to be -2. And the reason that it is that is because we have an oxygen rule. Okay, and we know that it is going to sum up to 0 because it is neutral. Okay, so I can kind of put this into an equation. So I know that it's going to be equal to 0. Potassium is +1. I don't know what manganese is. And oxygen is going to, there's 4 oxygens. And each oxygen is -2. So this will be -8. So +1 plus something -8 gives you 0. So the only thing that makes sense here is +7. So manganese will be +7. All right. Let's do another one. All right, in this example, it's asking us to find the oxidation number of sulfur. Okay, so we don't have a rule for sulfur. We do have a rule for oxygen. And in this case, we have an ion, so it's going to sum up to -2. So let's go through what we have. So oxygen is equal to -2. It's not a peroxide. And we know it's going to sum up to -2 for the ion. Okay, so if I put this into an equation, I've got whatever sulfur is. I have 3 oxygens each oxygen is -2, and that is going to equal -2. It will sum up to -2. So 3 times -2 is -6. So whatever sulfur is, -6 is going to be equal to -2. So if I'm trying to figure this out, the only thing that makes sense here is for sulfur to be equal to +4. 4 minus 6 is -2. So again, charge and oxidation number are not the same thing. Very important thing that you need to distinguish because they're very similar, but they're not the same. So sulfur, for example, has a charge of -2 normally, but in this case, it's +4. So oxidation number is not the same as charge. Okay, so again, when you're working through these problems and you have to understand or determine the value of an oxidation number, go through the rules that you have. First, figure out what those are, and you'll usually have a piece. In this case, the last case we had, it was sulfur, where you don't have a rule for, and you can usually figure out what the oxidation number is based on the other rules that you do have. Okay, so that is how we use oxidation numbers to, or rather, that's how we determine oxidation numbers when we're working redox reactions.